most of the 24 offsets. Hi, I'm George Crump, Lead Analyst with Storage Switzerland. Thank you for tuning in today. Joining me today on the whiteboard is Ritu Jyoti, Vice President of Product Management and Solutions at Kaminario Systems. How you doing, Ritu?
I'm doing very well, thank you, George.
Good. Hey, you know, one of the things that we talk about a lot with end users and also suppliers is we start to get into the flash space and talk about performance. One of the things I like to point out is if you don't have availability and your flash array goes down, performance really becomes a non-issue at that point because you're just dead in the water. Let's talk a little bit about resiliency and how that looks in the environment.
That's a great topic, George. I'd love to talk about it. So the way I'd like to do this is, again, we can start with some background information, what is our key attributes, and then how do we deliver this, right?
Okay.
So if you look into, very interestingly, what happened is that when flash arrays came into the existence, most of the initial deployments were as a very niche,
Right.
You were taking a little part of the data set and putting onto it.
Right. There was less risk involved.
Yeah,
Yeah.
and people were not really thinking like that. But we at Kaminario, right from the day one, we knew that we are building the next generation storage array.
Right.
And so if you look into the old flash arrays, they are actually, subjected to the same levels of reliability. They need to be reliable. They need to be consistent and predictable. They need to be highly available, right? And also resilient. If, it's okay, if there is a working, everything is fine, fantastic. But if there is a problem, how far do you recover from that?
Right.
And then last but not the least, they need to be very serviceable because, you're putting in your mission critical environments there. So the point that I'd like to make is this, that the flash arrays of today are actually being subjected to the same enterprise level SLAs, right?
Sure.
And all these are extremely, all the RAS characteristics is as important for flash arrays as it is for the traditional enterprise SANs
Right.
that the industry has gotten used
Well,
to.
flash array vendors are asking for enterprise workloads. They need to deliver this sort of enterprise.
You got it.
Yeah.
You got it. And Kaminario, right from the day one, we actually built it around that mindset. It's very surprising. People tell us that you guys are the only one who talk about storage characteristics, not just about performance. So
Right.
it's very important. Let's do a quick recap of what is K2 architecture from a RAS perspective. So if you look into we have multiple nodes, and each one the whole volume is distributed. We have multiple fiber channel HBAs and nice SCSI connections. So the key mindset was that there has to be no single point of failure, right? We have dual components for everything right into the architecture. The other very important thing is that there is N+1 data protect. What do I mean by that? And I'll explain it to you in the next section. But essentially, if a particular node fails, then we have a spare sitting out there which can actually take on those characteristics and maintain it. The third very important thing is that we support, when you're talking about high availability, one is from the, the architecture itself, right? The hardware components, different dual components, how you kind of maintaining multiple copies. But customers are demanding, as you said, when you're putting in your enterprise workloads, non-disruptive upgrades. This is very, very important, right? Customers cannot afford to have downtime.
Right.
The fourth very important thing is they have to be serviceable. So, right, we actually have 24/7. We give the customers the flexibility, that you can have for their mission critical environments, 24/7/4. If there are customers who need, next business day, so we provide them that option as well.
Okay.
And the very other important thing is that right from the get-go, because we are a company formed from all the storage experts from the industry, we have this proactive wellness, call home monitoring features, right?
Okay.
And we kind of, monitor it ahead of time and do some proactive wellness, on the system. So we are kind of looking into right from the mindset, the whole architecture and the design was that it has to be reliable, it has to be available, it has to be serviceable.
Okay.
Now let me walk through that how do we do this. So I'll do a very simplified way of, how do a K2 N+1 data protect works. We have multiple nodes, right?
Right.
And each of these nodes, they have primary and the secondary copies, right? And so what happens is when the data comes from the initiators, we randomly distribute it against all the available nodes. So for example, just simplistically, we had 1, 2, 3, and 4, and they are copied here, 2, 3, and 4, right?
Okay, right.
And we have a spare node sitting here. So if suppose there is a failure, this particular node goes down. So immediately we have the copies of this. 4 is already
all
here,
right there,
and
yeah.
3 is already there. So these, they actually become the primary, data services at that time, and we behind the scenes copy it to the spare because we don't want to have just one single copy.
Sure.
So if you look into this, even though we have lost one particular node, which was participating in our performance, we have parallelization. We have multiple servers actively participating, giving us very high performance during recovery. And we have, what we have noticed is that in most of the cases, it's about 15 to 20% degradation in performance during recovery, which is quite unheard of.
Right. Absolutely. Yeah.
And think about Flash. The performance is so good, and then on top of that, if you just see 15 to 20%, if you compare it with legacy,
Sure.
some of the arrays, they actually have about 80 to 90%
Right.
performance.
Right.
And the whole node failure, when it happens, it takes about 90 minutes for us to completely restore it back. Once you actually have the thing fixed, and then you
Okay.
bring it down. Some of the arrays, it takes about 4 to 6 hours.
Right.
And then, this is like, completely resilient. So, it's like, of course, we have consistent and linear performance,
Right.
but when, a performance a failure happens, because of our whole architecture and because of our N+1 data protect, it actually restores to its original position. And it's truly a resilient architecture built from the ground up with that mindset for mission critical enterprise environments.
So what I really like about here is you're talking about two things that I don't hear talked about enough in the flash industry. First of all, just high availability doesn't come up, right?
Exactly.
And then, what does performance look like when I do have a failure? Because we know something's going to break in the environment. That's why we have high
Exactly.
availability, right?
Exactly.
And if you're designing an environment counting on this type of performance,
Yeah.
a performance loss is just a massive issue. And so the fact that you guys are hitting both sides of that coin, I think, is a big advantage.
Indeed. And during this entire process, the application runs without any hiccups, right? And it is all happening self-healing behind the scenes. We restore it back to its original position. And I think, I'd like to keep on stressing that flash arrays are being subjected to the same critical scrutiny
Right.
if we are targeting for enterprise workloads.
Right.
So we have to match with all the stuff that the original, arrays were providing.
Agreed. If you don't do that, you will always be a niche product, right? So you got to be able to deliver enterprise capabilities.
Yes. So
No question.
resiliency certainly matters for flash arrays.
Well, thanks for joining us today.
Thank you. My
You're
pleasure.
welcome. I'm George Crump, Lead Analyst with Storage Switzerland. Thank you for tuning in.